Hello and welcome to this session. This is in continuation with the previous video where we were discussing the types of learning. So we have discussed supervised learning. Now let's understand what is unsupervised learning. Now unsupervised learning is little bit different than supervised learning. So here what we are going to give to the machine is a bunch of fruits, and I will not tell the machine what this fruit is. For example, here you may say I am providing an apple, banana, pear, orange, watermelon. So many different kinds of fruits I am giving to this machine, but I am not telling the machine that this is an orange, this is a pear. Like that I am not telling the machine. So the input that we are providing is not labeled. Earlier we saw we provided an apple and we also told the machine that this is an apple. Here I am not giving that information. So here I am only providing it lots of input. Now what this machine will do, it will take this input and it will try to extract the common features. So for orange, I'll not give one orange, I'll give multiple oranges. I'll give multiple watermelons, I'll give multiple apples. So now my machine is going to extract all this information and then it will try to classify or categorize them. So the machine learning algorithm will take all this input and it will try to build a model. What this model is going to do, it doesn't know what this fruit is, but it will try to categorize them. Means it will identify all the fruits which are having common characteristics as watermelon and it will put them in one cluster and it will internally put some label to that cluster. Similarly, it will identify all the fruits which have similar characteristics like that of orange. It will create another cluster and put them as orange. That is what this unsupervised learning will do. So now after that we provide a test data. So we are going to test. So we provide some image of watermelon, apple and orange. What this machine will do? It has already been trained on this kind of information. So it will use its predictive model and it will try to put them in the specified cluster. So watermelon will be put in watermelon cluster, apple will be put in watermelon apple cluster, sorry, and orange will be put in another cluster, that is orange. So the idea here is we are providing input but we are not providing the label. So whatever input we are providing, the machine is going to classify it based on different clusters. So clustering is the idea behind unsupervised learning. So this was the final result that the machine will give. So let's see what are the areas in which unsupervised learning can be used. So one area where it is used is credit card fraud detection. So whenever there are so many transactions happening, so the algorithm is means we give input lot of transactions that have been happening. Based on this, it will try to identify the pattern. If the transaction has been successfully done by the owner, or if there was a mistake in it, means there was a loss of money. That time, so this input has been provided. So whatever input the machine is getting, it will try to identify secured transaction and the fraudulent transaction. So next time when somebody tries to do a transaction based on this categorization or clustering, it will identify that maybe this is a fraud. So it will identify or alarm the user and will maybe a call may go to that person. Please check, is this the transaction you are performing or someone else is doing this transaction? So that is the area in which the unsupervised learning may be used. Another area where unsupervised learning is commonly used is the product recommendation. Now this is something I think every one of us has come across. Whenever we try to buy a product, there will be list of similar products that we might be interested in buying. So what the machine is doing or what they are doing is they are keeping a track of the kind of purchasing different people are doing. And then they try to cluster it up. Like women are buying these of this age group are buying these things commonly. The men of this age group are buying these things commonly. So like that they have clustered the thing. So next time when a person goes for shopping, they identify to which cluster they belong and accordingly they get the product recommendation. So this is another area where unsupervised learning is commonly used. Now let's compare supervised learning and unsupervised learning. So in supervised learning, there is a clarity and we have a label. So simply we have to classify the input as whether it falls in one category or it falls in another category. So we have a clarity very much clear that either it will be falling in this category or that category. Whereas in unsupervised learning, we don't have the input labels, but the machine has been provided input, and based on that, the machine has itself created a cluster. So these clusters are now like labeled input. So next time when our input test data is provided, the model is going to predict and put it into the specified cluster. That is the idea behind unsupervised learning. Now let's proceed with the next one, that is reinforcement learning. So let's understand what is reinforcement learning. Again, suppose we have provided an input and we are telling the machine what it is. Means we have built a model, and based on that we are giving the input and we are asking the model what it is. Now what the response will the machine will give? Maybe it says it is a mango. So if it is giving me the wrong input, then what I'm going to do, I will teach the machine, no, this is incorrect. It is not an apple. It is, sorry, it's not a mango, it's an apple. So that is the kind of input we are providing to the machine. So now what the machine will do, it will try to learn this information. It did a mistake. So from the mistake, it is learning. So it will say, okay, I have noted this. Next time I will remember this. So first the model was built. Based on this, we tested the model, but the model predicted the wrong output. Based on the wrong output, that information was again given to this machine. So reinforce, we are saying, okay, relearn the concept based on the wrong output you have delivered. So now the machine learns. And next time we use the same input, we give the model, and this time it is producing the output, that is the reinforced output. So now it successfully predicts, okay, this is an apple. So that is how reinforcement learning works. This is basically used in the gaming applications. So what happens in gaming application? When the model starts playing the game, there will be certain cases where there is a win. Sometimes he will not win, he will lose. So in this case, whenever he wins, he gets some reward. But whenever he fails, then he gets a kind of penalty. So based on this reward and penalty, the model is learning. So next time when he plays, he knows that I need to have a reward. I don't need a penalty. So step by step, it will keep on learning and will be more accurate in predicting the output. So there are several types of gaming applications where you need to reach to the target, and in between you might get hurt or eaten up by the demon or something. So these are the areas of reinforcement learning. So here what we have seen is we have a learning concept where we are giving input to the model. The model is learning based on the input and it is predicting the output. Then we evaluate the model based on the actual targeted value. There are three types of learning: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is where we provide the input, labeled input, and the machine has to predict or classify the input as label A or label B. Whereas in unsupervised learning, there is no label. So the machine itself, based on the input data, it will put them into different clusters. So classification kind of problem will be created. So once the cluster is created, it is now like a supervised model. So next time when I provide the input, the model has to place me into the appropriate cluster. And finally, we have reinforcement learning, where there is something kind of penalty and reward mechanism. Every time the model predicts the correct output, it gains a reward. If it predicts a wrong output, there will be a penalty. So that penalty works as an input to the system so that the machine enhances itself and it doesn't do the same mistake again. So that's all for machine learning types. So let's stop here. Thank you very much.